Chapter 8. Techniques of Flight Instruction. Introduction. Certificated Flight Instructor, CFI, Daniel, decides his student Mary has gained enough confidence in flying that it is time for her to develop personal weather minimums. While researching the subject at the Federal Aviation Administration, FAA, website, he locates several sources that provide background information, such as the fact that, statistically, weather often poses some of the greatest risks to general aviation GA pilots, regardless of their experience level. He also finds charts and a lesson plan he can use. Daniel's decision to help Mary develop personal weather minimums reflects a key component of the flight instructor's job, providing the student with the tools to ensure safety during a flight. Every flight instructor can agree that everyone wants to be safe, but what does safety really mean? How can a flight instructor ensure the safety of flight training activities and also train clients to operate their aircraft safely after they leave the relatively protected flight training environment? According to one definition, safety is the freedom from conditions that can cause death, injury, or illness, damage to or loss of equipment or property, or damage to the environment. FAA regulations are intended to promote safety by eliminating or mitigating conditions that can cause death, injury, or damage. These regulations are comprehensive, but there has been increasing recognition that even the strictest compliance with regulations may not be sufficient to guarantee safety. Rules and regulations are designed to address known or suspected conditions detrimental to safety, but there is always the probability that some new combination of circumstances, not contemplated by the regulations, will arise. The recognition of aviation training and flight operations has led to a system approach to aviation safety. Since flight instructors are a critical part of the aviation safety system, this chapter introduces system safety, aeronautical decision-making, ADM, risk management, situational awareness, and single pilot resource management, SRM, in the modern flight training environment. It also provides methods flight instructors can teach students to use practical risk management tools and discusses how to evaluate student decision-making. The chapter begins with practical strategies flight instructors can use to enhance their instruction, the demonstration performance training delivery method of flight instruction, integrated flight instruction, positive exchange of flight controls, use of distractions, obstacles to learning encountered during flight training, and how to evaluate students. After an intensive look at ADM, it closes with a discussion of CFI recommendations and endorsements. Flight instructor qualifications. A CFI must be thoroughly familiar with the functions, characteristics, and proper use of all flight instruments, avionics, and other aircraft systems being used for training. This is especially important due to the wide variety of global positioning system, GPS, and glass panel displays. It is the personal responsibility of each flight instructor to maintain familiarity with current pilot training techniques and certification requirements. This may be done by frequent review of new periodicals and technical publications, personal contacts with FAA inspectors and designated pilot examiners, DPE, and by participation in pilot and flight instructor clinics. Additional information can be obtained from veteran flight instructors, Figure 8-1. The application of outmoded instructional procedures or the preparation of students using obsolete certification requirements is inexcusable. Practical flight instructor strategies. During all phases of flight training, CFIs should remember they are role models for the student. The flight instructor should demonstrate good aviation sense at all times. Before the flight, discuss safety and importance of proper pre-flight and use of the checklist. During flight, prioritize the tasks of aviating, navigating, and communicating. Instill importance of see and avoid in the student. During landing, conduct stabilized approaches. Maintain desired airspeed on final. Demonstrate good judgment for go-arounds, wake turbulence, traffic, and terrain avoidance. Use ADM to correct faulty approaches and landing errors. Make power off, stall warning blaring, on centerline touchdowns in the first third of runway. Always remember, safety is paramount. Flight instructors have the responsibility of producing the safest pilots possible. For that reason, CFIs should encourage each student to learn as much as he or she is capable of and keep raising the bar. When introducing lesson tasks, flight instructors should not introduce the minimum acceptable standards for passing the checkride. The Practical Test Standard, PTS, is not a teaching tool. It is a testing tool. The overall focus of flight training should be on education, learning, and understanding why the standards are there and how they were set. The minimum standards to pass the checkride should not be introduced until the 3 hours of preparation for the checkride. Obstacles to learning during flight instruction. Certain obstacles are common to flight instruction and may apply directly to the student's attitude, physical condition, and psychological makeup. These include, but are not limited to, feeling of unfair treatment, impatience to proceed to more interesting operations, worry or lack of interest, physical discomfort, illness, fatigue, and dehydration, apathy due to inadequate instruction, anxiety. Unfair treatment. Students who believe their instruction is inadequate or that their efforts are not conscientiously considered and evaluated do not learn well. In addition, their motivation suffers, no matter how intent they are on learning to fly. Motivation also declines when a student believes the instructor is making unreasonable demands for performance and progress. Figure 8-2. Assignment of goals the student considers difficult but possible usually provides a challenge and promotes learning. In a typical flight lesson, reasonable goals are listed in the lesson objectives, and the desired levels of proficiency for the goals are included in statements that contain completion standards. Impatience. Impatience is a greater deterrent to learning pilot skills than is generally recognized. For a student, this may take the form of a desire to make an early solo flight or to set out on cross-country flights before the basic elements of flight have been learned. The impatient student fails to understand the need for preliminary training and seeks only the ultimate objective without considering the means necessary to reach it. With every complex human endeavor, it is necessary to master the basics if the whole task is to be performed competently and safely. The instructor can correct student impatience by presenting the necessary preliminary training one step at a time, with clearly stated goals for each step. The procedures and elements mastered in each step should be clearly identified in explaining or demonstrating the performance of the subsequent step. Impatience can result from instruction keyed to the pace of a slow learner when it is applied to a motivated, fast learner. It is just as important that a student be advanced to the subsequent step as soon as one goal has been attained, as it is to complete each step before the next one is undertaken. Disinterest grows rapidly when unnecessary repetition and drill are requested on operations that have already been adequately learned. Worry or lack of interest. Worry or lack of interest has a detrimental effect on learning. Students who are worried or emotionally upset are not ready to learn and derive little benefit from instruction. Worry or distraction may be due to student concerns about progress in the training course, or may stem from circumstances completely unrelated to their instruction. Significant emotional upsets may be due to personal problems, psychiatric disturbances, or a dislike of the training program or the instructor. The experiences of students outside their training activities affect behavior and performance in training. The two cannot be separated. When students begin flight training, they bring with them their interests, enthusiasms, fears, and troubles. The instructor cannot be responsible for these outside diversions, but cannot ignore them because they have a critical effect on the learning process. Instruction must be keyed on the utilization of the interests and enthusiasm students bring with them, and to diverting their attention from their worries and troubles to learning the task at hand. This is admittedly difficult, but must be accomplished if learning is to proceed at a normal rate. Worries and emotional upsets that result from a flight training course can be identified and addressed. These problems are often due to inadequacies of the course or of the instructor. The most effective cure is prevention. The instructor must be alert and ensure students understand the objectives of each step of their training, and that they know at the completion of each lesson exactly how well they have progressed and what deficiencies are apparent. Discouragement and emotional upsets are rare when students feel that nothing is being withheld from them or is being neglected in their training. Physical discomfort, illness, fatigue, and dehydration. Physical discomfort, illness, and fatigue will materially slow the rate of learning during both classroom instruction and flight training. Students who are not completely at ease and whose attention is diverted by discomforts such as the extremes of temperature, poor ventilation, inadequate lighting, or noise and confusion cannot learn at a normal rate. This is true no matter how diligently they attempt to apply themselves to the learning task. A minor illness, such as a cold, major illness, or injury, interferes with the normal rate of training. This is especially important for flight instruction. Most illnesses adversely affect the acuteness of vision, hearing, and feeling, all of which are essential to correct performance. Air sickness can be a great deterrent to flight instruction. A student who is airsick or bothered with incipient air sickness is incapable of learning at a normal rate. There is no sure cure for air sickness, but resistance or immunity usually can be developed in a relatively short period of time. An instructional flight should be terminated as soon as an incipient illness is experienced. As the student develops immunity, flights can be increased in length until normal flight periods are practicable. Keeping students interested and occupied during flight is a deterrent to air sickness. They are much less apt to become airsick while operating the controls themselves. Rough air and unexpected abrupt maneuvers tend to increase the chances of air sickness. Tension and apprehension apparently contribute to air sickness and should be avoided. Fatigue. Fatigue is one of the most treacherous hazards to flight safety, as it may not be apparent to a pilot until serious errors are made. Fatigue can be either acute, short-term, or chronic, long-term. Acute fatigue, a normal occurrence of everyday living, is the tiredness felt after long periods of physical and mental strain, including strenuous muscular effort, immobility, heavy mental workout, strong emotional pressure, monotony, and lack of sleep. Acute fatigue, caused by training operations, may be physical or mental or both. It is not necessarily a function of physical robustness or mental acuity. The amount of training any student can absorb without incurring debilitating fatigue varies. Generally speaking, complex operations tend to induce fatigue more rapidly than simpler procedures do, regardless of the physical effort involved. Fatigue is the primary consideration in determining the length and frequency of flight instruction periods, and flight instruction should be continued only as long as the student is alert, receptive to instruction, and is performing at a level consistent with experience. It is important for a CFI to be able to detect fatigue both in assessing a student's substandard performance early in a lesson and also in recognizing the deterioration of performance. If fatigue occurs as a result of application to a learning task, the student should be given a break in instruction and practice. A CFI who is familiar with the signs indicative to acute fatigue will be more aware if the student is experiencing them. The deficiencies listed below are apparent to others before the individual notices any physical signs of fatigue. Acute fatigue is characterized by inattention, distractibility, errors in timing, neglect of secondary tasks, loss of accuracy and control, lack of awareness of error accumulation, irritability. Another form of fatigue is chronic fatigue, which occurs when there is not enough time for full recovery from repeated episodes of acute fatigue. Chronic fatigue's underlying cause is generally not rest-related and may have deeper points of origin. Therefore, rest alone may not resolve chronic fatigue. Chronic fatigue is a combination of both physiological problems and psychological issues. Psychological problems, such as financial, home life, or job-related stresses, cause a lack of qualified rest that is only solved by mitigating the underlying problems before the fatigue is solved. Without resolution, human performance continues to fall off and judgment becomes impaired so that unwarranted risks may be taken. Recovery from chronic fatigue requires a prolonged and deliberate solution. In either case, unless adequate precautions are taken, personal performance could be impaired and adversely affect pilot judgment and decision-making. Dehydration and heat stroke. Dehydration is the term given to critical loss of water from the body. Dehydration reduces a pilot's level of alertness, producing a subsequent slowing of decision-making processes or even the inability to control the aircraft. The first noticeable effect of dehydration is fatigue, which in turn makes top physical and mental performance difficult, if not impossible. Flying for long periods in hot summer temperatures or at high altitudes increases susceptibility to dehydration, since dry air at high altitudes tends to increase the rate of water loss from the body. If this fluid is not replaced, fatigue progresses to dizziness, weakness, nausea, tingling of hands and feet, abdominal cramps, and extreme thirst. Heat stroke is a condition caused by any inability of the body to control its temperature. Onset of this condition may be recognized by the symptoms of dehydration, but also has been known to be recognized only by complete collapse. To prevent these symptoms, it is recommended that an ample supply of water be carried and used at frequent intervals on any long flight, whether the pilot is thirsty or not. If the airplane has a canopy or roof window, wearing light-colored, porous clothing and a hat helps provide protection from the sun. Keeping the flight deck well ventilated aids in dissipating excess heat. Apathy due to inadequate instruction. Students can become apathetic when they recognize that the instructor has made inadequate preparations for the instruction being given, or when the instruction appears to be deficient, contradictory, or insincere. To hold the student's interest and to maintain the motivation necessary for efficient learning, well-planned, appropriate, and accurate instruction must be provided. Nothing destroys a student's interest as quickly as poorly organized period of instruction. Even an inexperienced student realizes immediately when the instructor has failed to prepare for a lesson. Figure 8-3. Instruction may be overly explicit and so elementary it fails to hold student interest, or it may be so general or complicated that it fails to evoke the interest necessary for effective learning. To be effective, the instructor must teach for the level of the student. The presentation must be adjusted to be meaningful to the person for whom it is intended. For example, instruction in the pre-flight inspection of an aircraft should be presented quite differently for a student who is a skilled aircraft maintenance technician, AMT, compared to the instruction on the same operation for a student with no previous aeronautical experience. The instruction needed in each case is the same, but a presentation meaningful to one of these students might not be appropriate for the other. Poor instructional presentations may result not only from poor preparation, but also from distracting mannerisms, personal untidiness, or the appearance of irritation with the student. Creating the impression of talking down to the student is one of the fastest ways for an instructor to lose student confidence and attention. Once the instructor loses student confidence, it is difficult to regain, and the learning rate is unnecessarily diminished. Anxiety. Student anxiety may place additional burdens on the instructor. This frequently limits the student's perceptive ability and retards the development of insights. The student must be comfortable, confident in the instructor and the aircraft, and at ease if effective learning is to occur. Providing this atmosphere for learning is one of the first and most important tasks of the instructor. Although doing so may be difficult at first, successive accomplishment of recognizable goals and avoidance of alarming occurrences or situations will rapidly ease the student's mind. This is true of all flight students, but special handling by the instructor may be required for students who are obviously anxious or uncomfortable. Demonstration Performance Training Delivery Method. The demonstration performance training delivery method was discussed briefly in Chapter 4, The Teaching Process, but the following in-depth discussion is geared to the flight instructor. This training method has been in use for a long time and is very effective in teaching kinesthetic skills, so flight instructors find it valuable in teaching procedures and maneuvers. The demonstration performance method is divided into 4 phases: explanation, demonstration, student performance with instructor supervision, and evaluation. Figure 8-4. Explanation phase. The flight instructor needs to be well prepared and highly organized if complex maneuvers and procedures are to be taught effectively. The student must be intellectually and psychologically ready for the learning activity. The explanation phase is accomplished prior to the flight lesson with a discussion of lesson objectives and completion standards, as well as a thorough pre-flight briefing. Explanations must be clear, pertinent to the objectives of the particular lesson to be presented, and based on the known experience and knowledge of the students. Students need to know not only what they will learn, but also how they will learn it. That is, how the lesson will proceed and how they will be evaluated. In teaching a skill, the instructor must convey to the students the precise actions they are to perform. In addition to the necessary steps, the instructor should describe the end result of these efforts. The explanation phase also should include coverage of appropriate safety procedures. Before leaving this phase, the instructor should encourage students to ask questions about any step of the procedure that they do not understand. Demonstration phase. The instructor must show students the actions necessary to perform a skill. As little extraneous activity as possible should be included in the demonstration if students are to clearly understand that the instructor is accurately performing the actions previously explained. If, due to some unanticipated circumstances, the demonstration does not closely conform to the explanation, this deviation should be immediately acknowledged and explained. Student performance and instructor supervision phases. As discussed in Chapter 4, these 2 phases involve separate actions that are performed concurrently. The first of these phases is the student's performance of the physical or mental skills that have been explained and demonstrated. The second activity is the instructor's supervision. Student performance requires students to act and do. To learn skills, students must practice. The instructor must, therefore, allot enough time for meaningful student activity. Through doing, students learn to follow correct procedures and to reach established standards. It is important that students be given an opportunity to perform the skill as soon as possible after a demonstration. Then, the instructor reviews what has been covered during the instructional flight and determines to what extent the student has met the objectives outlined during the pre-flight discussion. The instructor should be satisfied that the student is well prepared and understands the task before starting. The instructor observes as the student performs and then makes appropriate comments. Evaluation phase. In this phase, the instructor traditionally evaluates student performance, records the student's performance, and verbally advises the student of the progress made toward the objectives. Regardless of how well a skill is taught, there may still be performance deficiencies. When pointing out areas that need improvement, offer concrete suggestions that help. If possible, avoid ending the evaluation on a negative note. As discussed in Chapter 5, assessment, collaborative assessment, or learner-centered grading, LCG, is a form of authentic assessment currently used in aviation training with problem-based learning, PBL. PBL structures the lessons to confront the students with problems that are encountered in real life and forces them to reach real-world solutions. Scenario-based training, SBT, a type of PBL, uses a highly structured script of real-world experiences to address aviation training objectives in an operational environment. Collaborative assessment is used to evaluate whether certain learning criteria were met during the SBT. Collaborative assessment includes 2 parts: learner self-assessment and a detailed assessment by the flight instructor. The purpose of the self-assessment is to stimulate growth in the learner's thought processes and, in turn, behaviors. The self-assessment is followed by an in-depth discussion between the instructor and the student, which compares the instructor's assessment to the student's self-assessment. The telling and doing technique. The demonstration performance method can be applied to the telling and doing technique of flight instruction in 3 steps: However, the telling and doing technique includes specific variations for flight instruction. Figure 8-5. Instructor tells, instructor does. First, the flight instructor gives a carefully planned demonstration of the procedure or maneuver with accompanying verbal explanation. While demonstrating in-flight maneuvers, the instructor should explain the required power settings, aircraft attitudes, and describe any other pertinent factors that may apply. This is the only step in which the student plays a passive role. It is important for the demonstration to conform to the explanation as closely as possible. In addition, it should be demonstrated in the same sequence in which it was explained, so as to avoid confusion and provide reinforcement. Since students generally imitate the instructor's performance, the instructor must demonstrate the skill exactly the way the students are expected to practice it, including all safety procedures that the students must follow. If, due to some unanticipated circumstances, the demonstration does not closely conform to the explanation, this deviation should be immediately acknowledged and explained. Most physical skills lend themselves to a sequential pattern where the skill is explained in the same step-by-step order normally used to perform it. When the skill being taught is related to previously learned procedures or maneuvers, the known to unknown strategy may be used effectively. When teaching more than one skill at a time, the simple to complex strategy works well. By starting with the simplest skill, the student gains confidence and is less likely to become frustrated when faced with building skills that are more complex. Another consideration in this phase is the language used. Instructors should attempt to avoid unnecessary jargon and technical terms that their students do not know. Instructors should also take care to clearly describe the actions students are expected to perform. Communication is the key. It is neither appropriate nor effective for instructors to try to impress students with their expertise by using language that is unnecessarily complicated. As an example, a level turn might be demonstrated and described by the instructor in the following way. Use outside visual references and monitor the flight instruments. After clearing the airspace around the aircraft, add power slightly, turn the aircraft to the desired direction, and apply a slight amount of back pressure on the yoke to maintain altitude. Maintain coordinated flight by applying the rudder in the direction of the turn. Remember, the ailerons control the roll rate as well as the angle of bank. The rate at which the aircraft rolls depends on how much aileron deflection is used. How far the aircraft rolls, steepness of the bank, depends on how long the ailerons are deflected, since the aircraft continues to roll as long as the ailerons are deflected. When the desired angle of bank is reached, neutralize the ailerons and trim as appropriate. Lead the rollout by approximately 1/2 the number of degrees of the angle of bank. Use coordinated aileron and rudder control pressures. Simultaneously begin releasing the back pressure so aileron, rudder, and elevator pressures are neutralized when the aircraft reaches the wings level position. Leading the rollout heading by 1/2 the bank angle is a good rule of thumb for initial training. However, keep in mind that the required amount of lead really depends on the type of turn rate, and rollout rate. As a pilot gains experience, he or she will develop a consistent roll-in and roll-out technique for various types of turns. Upon reaching a wings level attitude, reduce power and trim to remove control pressures. Student tells, instructor does. Second, the student tells as the instructor does. In this step, the student actually plays the role of instructor, telling the instructor what to do and how to do it. Two benefits accrue from this step. The student, being freed from the need to concentrate on performance of the maneuver and from concern about its outcome, is able to organize his or her thoughts regarding the steps involved and the techniques to be used. In the process of explaining the maneuver as the instructor performs it, perceptions begin to develop into insights. Mental habits begin to form with repetition of the instructions previously received. Plus, the instructor is able to evaluate the student's understanding of the factors involved in performance of the maneuver. According to the principle of primacy, it is important for the instructor to make sure the student gets it right the first time. The student should also understand the correct sequence and be aware of safety precautions for each procedure or maneuver. If a misunderstanding exists, it can be corrected before the student becomes absorbed in controlling the aircraft. Student tells, student does. Application is the third step of this method. This is where learning takes place and where performance habits are formed. If the student has been adequately prepared and the procedure or maneuver fully explained and demonstrated, meaningful learning occurs. The instructor should be alert during the student's practice to detect any errors in technique and to prevent the formation of faulty habits. At the same time, the student should be encouraged to think about what to do during the performance of a maneuver until it becomes habitual. In this step, the thinking can be done verbally. This focuses concentration on the task to be accomplished, so the total involvement in the maneuver is fostered. All of the student's physical and mental faculties are brought into play. The instructor should be aware of the student's thought processes. It is easy to determine whether an error is induced by a misconception or by a simple lack of motor skills. Therefore, in addition to forcing total concentration on the part of the student, this method provides a means for keeping the instructor aware of what the student is thinking. The student is not only learning to do something, but he or she is also learning a self-teaching process that is highly desirable in development of a skill. The exact procedures that the instructor should use during student practice depends on factors such as the student's proficiency level, the type of maneuver, and the stage of training. The instructor must exercise good judgment to decide how much control to use. With potentially hazardous or difficult maneuvers, the instructor should be alert and ready to take control at any time. This is especially true during a student's first attempt at a particular maneuver. On the other hand, if a student is progressing normally, the instructor should avoid unnecessary interruptions or too much assistance. A typical test of how much control is needed often occurs during a student's first few attempts to land an aircraft. The instructor must quickly evaluate the student's need for help and not hesitate to take control if required. At the same time, a student should be allowed to practice the entire maneuver often enough to achieve the level of proficiency established in the lesson objectives. Since this is a learning phase rather than an evaluation phase of the training, errors or unsafe practices should be identified and corrected in a positive and timely way. In some cases, the student is not able to meet the proficiency level specified in the lesson objectives within the allotted time. When this occurs, the instructor should be prepared to schedule additional training. Positive exchange of flight controls. Positive exchange of flight controls is an integral part of flight training. It is especially critical during the demonstration performance method of flight instruction. Due to the importance of this subject, the following discussion provides guidance on the recommended procedure to use with a positive exchange of flight controls between pilots when operating an aircraft. Background. Incident/accident statistics indicate a need to place additional emphasis on the exchange of control of an airplane by pilots. Numerous accidents have occurred due to a lack of communication or misunderstanding regarding who had actual control of the aircraft, particularly between students and flight instructors. Establishing the following procedure during initial training will ensure the formation of a habit pattern that should stay with students throughout their flying careers. Procedure. During flight training, there must always be a clear understanding between students and flight instructors about who has control of the aircraft. The pre-flight briefing should include procedures for the exchange of flight controls. A positive three-step process in the exchange of flight controls between pilots is a proven procedure and one that is strongly recommended. When an instructor is teaching a maneuver to a student, the instructor normally demonstrates the maneuver first, then has the student follow along on the controls during a demonstration, and finally, the student performs the maneuver with the instructor following along on the controls. Figure 8-6. Figure 8-6 text. During this procedure, a visual check is recommended to see that the other person actually has the flight controls. When returning the controls to the instructor, the student should follow the same procedure the instructor used when giving the control to the student. The student should stay on the controls and keep flying the aircraft until the instructor says, "I have the controls." There should never be any doubt about who is flying the aircraft. Positive exchange of flight controls. 1. When the instructor wishes the student to take control of the aircraft, the instructor says to the student, "You have the flight controls." 2. The student acknowledges immediately by saying, "I have the flight controls." 3. The flight instructor again says, "You have the flight controls." End of Figure 8-6. Flight instructors should always guard the controls and be prepared to take control of the aircraft. When necessary, the instructor should take the controls and calmly announce, "I have the flight controls." If an instructor allows a student to remain on the controls, the instructor may not have full and effective control of the aircraft. Anxious students can be incredibly strong and usually exhibit reactions inappropriate to the situation. If a recovery is necessary, there is absolutely nothing to be gained by having the student on the controls and having to fight for control of the aircraft. Students should never be allowed to exceed the flight instructor's limits. Flight instructors should not exceed their own ability to perceive a problem, decide on the course of action, and physically react within their ability to fly the aircraft. Sterile Cockpit Rule. Commonly known as the Sterile Cockpit Rule, Title 14 of the Code of Federal Regulations, 14 CFR, Section 121.542, requires flight members to refrain from non-essential activities during the critical phases of flight. As defined in the regulation, critical phases of flight are all ground operations involving taxi, takeoff, and landing, and all other operations below 10,000 feet, except cruise flight. Non-essential activities, including such activities as eating, reading a newspaper, or chatting. A series of aircraft accidents caused by flight crews who were distracted from their flight duties during critical phases of flight caused the FAA to propose the rule. While the regulation grew out of accidents in the airline industry, it holds true for the entire aviation community. Pilots can improve flight safety significantly by reducing distractions during critical phases of flight. It is important the flight instructor not only teach the concept of a sterile cockpit, but also model such behavior during flight instruction. Use of distractions. National Transportation Safety Board, NTSB statistics reveal that most stall/spin accidents occurred when the pilot's attention was diverted from the primary task of flying the aircraft. 60% of stall/spin accidents occurred during takeoff and landing, and 20% were preceded by engine failure. Preoccupation inside or outside the flight deck while changing aircraft configuration or trim, maneuvering to avoid other traffic, or clearing hazardous obstacles during takeoff and climb could create a potential stall/spin situation. The intentional practice of stalls and spins seldom resulted in an accident. The real danger was inadvertent stalls induced by distractions during routine flight situations. Pilots at all skill levels should be aware of the increased risk of entering into an inadvertent stall or spin while performing tasks that are secondary to controlling the aircraft. The FAA has established a policy for use of certain distractions on practical tests for pilot certification. The purpose is to determine that applicants possess the skills required to cope with distractions while maintaining the degree of aircraft control required for safe flight. The most effective training is the simulation of scenarios that can lead to inadvertent stalls by creating distractions while a student is practicing certain maneuvers. Instructor responsibilities include teaching the student to divide his or her attention between the distracting task and maintaining control of the aircraft. The following are examples of distractions that can be used for this training. Drop a pencil. Ask the student to pick it up. Ask the student to determine a heading to an airport using a chart. Ask the student to reset the clock. Ask the student to get something from the back seat. Ask the student to read the outside air temperature. Ask the student to call the Automated Flight Service Station, AFSS, for weather information. Ask the student to compute true airspeed with a flight computer. Ask the student to identify terrain or objects on the ground. Ask the student to identify a field suitable for a forced landing. Have the student climb 200 feet and maintain altitude, and then descend 200 feet and maintain altitude. Have the student reverse course after a series of S-turns. It is the flight instructor's responsibility to teach the student how to take charge during a flight. A pilot in command, PIC, must know when to tell any passengers, even a DPE, when the PIC finds actions in the aircraft that distract and interfere with the safe conduct of the flight. Integrated flight instruction. Integrated flight instruction is flight instruction during which students are taught to perform flight maneuvers both by outside visual references and by reference to flight instruments. For this type of instruction to be fully effective, the use of instrument references should begin the first time each new maneuver is introduced. No distinction in the pilot's operation of the flight controls is permitted, regardless of whether outside references or instrument indications are used for the performance of the maneuver. When this training technique is used, instruction in the control of an aircraft by outside visual references is integrated with instruction in the use of flight instrument indications for the same operations. Development of habit patterns. It is important for the student to establish the habit of observing and relying on flight instruments from the beginning of flight training. It is equally important for the student to learn the feel of the airplane while conducting maneuvers, such as being able to feel when the airplane is out of trim or in a nose-high or nose-low attitude. Students who have been required to perform all flight maneuvers by reference to instruments as well as by outside references develop from the start the habit of continuously monitoring their own and the aircraft's performance. The early establishment of proper habits of instrument cross-check, instrument interpretation, and aircraft control is highly useful to the student. The habitual attention to instrument indications leads to improved landings because of more precise airspeed control. Effective use of instruments also results in superior cross-country navigation, better coordination, and generally a better overall pilot competency level. General aviation accident reports provide ample support for the belief that reference to flight instruments is important to safety. The safety record of pilots who hold instrument ratings is significantly better than that of pilots with comparable flight time who have never received formal flight training for an instrument rating. Pilots in training who have been required to perform all normal flight maneuvers by reference to instruments, as well as by outside references, will develop from the start the habit of continuously monitoring their own and the aircraft's performance. The early establishment of proper habits of instrument cross-check, instrument interpretation, and aircraft control is highly useful to the student. The habits formed at this time also give him or her a firm foundation for the later training of an instrument rating. Operating efficiency. As students become proficient in monitoring and correcting their own flight technique by reference to flight instruments, the performance obtained from an aircraft increases noticeably. This is particularly true of modern complex or high-performance aircraft, which are responsive to the use of correct operating airspeeds. The use of correct power settings and climb speeds, and the accurate control of headings during climbs result in a measurable increase in climb performance. Holding precise headings and altitudes in cruising flight definitely increases average cruising performance. The use of integrated flight instruction provides the student with the ability to control an aircraft in flight for limited periods if outside references are lost. In an emergency, this ability could save the pilot's life and those of the passengers. During the conduct of integrated flight training, the flight instructor must emphasize to the students that the introduction to the use of flight instruments does not prepare them for operations in marginal weather or instrument meteorological conditions, IMC. The possible consequences, both to themselves and to others, of experiments with flight operations in weather conditions below visual flight rules, VFR minimums, before they are instrument rated, should be constantly impressed on the students. According to NTSB accident data, in-flight encounters with weather, attempting VFR flight into IMC, is one of the most lethal types of GA flying. Procedures. Integrated flight instruction begins with the first briefing on the function of the flight controls. This briefing includes the instrument indications to be expected, as well as the outside references to be used to control the attitude of the aircraft. Each new maneuver is introduced using both outside and instrument references, with students developing the ability to maneuver an aircraft equally as well by instrument or outside references. They naturally accept the fact that the manipulation of the flight controls is identical, regardless of which references are used to determine the attitude of the aircraft. This practice should continue throughout the flight instruction for all maneuvers. To fully achieve the demonstrated benefits of this type of training, the use of visual and instrument references must be constantly integrated throughout the training. Failure to do so lengthens the flight instruction necessary for the student to achieve the competency required for the private pilot certificate. See and avoid. From the start of flight training, the instructor must ensure students develop the habit of looking for other air traffic at all times. If students believe the instructor assumes all responsibility for scanning and collision avoidance procedures, they do not develop the habit of maintaining a constant vigilance, which is essential to safety. Any observed tendency of a student to enter flight maneuvers without first making a careful check for other air traffic must be corrected immediately. Recent studies of mid-air collisions determined that flight instructors were on board the aircraft in 37% of the accidents in the study. Most of the aircraft involved in collisions were engaged in recreational flying, not on any type of flight plan. Most mid-air collisions occur in VFR weather conditions during weekend daylight hours. The vast majority of accidents occurred at or near non-towered airports and at altitudes below 1,000 feet. Pilots of all experience levels were involved in mid-air collisions, from pilots on their first solo to 20,000-hour veterans. Most collisions occur in daylight with visibility greater than 3 miles. It is imperative to introduce 14 CFR Section 91.113 right-of-way rules to the student. Practice the see and avoid concept at all times, regardless of whether the training is conducted under VFR or Instrument Flight Rules, IFR. For more information on how to reduce the odds of becoming involved in a mid-air collision, see www.faa.gov/about/office_org/ATO/TRACON, Assessment of piloting ability. Assessment is an essential component of the teaching process. It determines how, what, and how well a student is learning. A well-designed assessment provides a student with something constructive upon which he or she can work or build. An assessment should provide direction and guidance to raise the level of performance. Students must understand the purpose of the assessment. Otherwise, they will be unlikely to accept the evaluation offered, and little improvement will result. There are many types of assessment, but the flight instructor generally uses the review, collaborative assessment, LCG, written tests, and performance-based tests to ascertain knowledge or practical skill levels. Refer to Chapter 5 for an in-depth discussion of the types of assessment available to the flight instructor. An assessment can also be used as a tool for reteaching. Although not all assessments lend themselves to reteaching, the instructor should be alert to the possibility and take advantage of the opportunity when it arises. In assessing the ability of a student, the instructor initially determines if he or she understands the procedure or maneuver. Then, the instructor demonstrates the maneuver, allows the student to practice the maneuver under direction, and finally evaluates student accomplishment by observing the performance. Demonstrated ability. Assessment of demonstrated ability during flight instruction must be based upon established standards of performance, suitably modified to apply the student's experience and stage of development as a pilot. The assessment must consider the student's mastery of the elements involved in the maneuver, rather than merely the overall performance. In order for a student to be signed off for a solo flight, the CFI must determine that the student is qualified and proficient in the flight tasks necessary for the flight. The CFI bases this assessment on the student's ability to demonstrate consistent proficiency on a number of flight maneuvers. Also associated with pilot skill evaluations during flight training are the stage checks conducted in FAA-approved school courses and their practical tests for pilot certificates and ratings. Post-flight evaluation. In assessing piloting ability, it is important for the flight instructor to keep the student informed of progress. This may be done as each procedure or maneuver is completed or summarized during the post-flight critiques. Post-flight critiques should be in a written format, such as notes to aid the flight instructor in covering all areas that were noticed during the flight or lesson. Traditionally, flight instructors explained errors in performance, pointed out elements in which the deficiencies were believed to have originated, and, if possible, suggested appropriate corrective measures. Traditional assessment depends on a grading scale of excellent, good, fair, poor, or exceeds standards, meets standards, needs more training, which often meets the instructor's needs, but not the needs of the student. With the advent of SBT, collaborative assessment is used whenever the student has completed a scenario. As discussed in chapters 4 and 5, SBT uses a highly structured script of real-world experiences to address aviation training objectives in an operational environment. During the post-flight evaluation, collaborative assessment is used to evaluate whether certain learning criteria were met during the SBT. Collaborative assessment includes learner self-assessment and a detailed assessment by the aviation instructor. The purpose of the self-assessment is to stimulate growth in the learner's thought processes and, in turn, behaviors. The self-assessment is followed by an in-depth discussion between the instructor and the student, which compares the instructor's assessment to the student's self-assessment. First solo flight. During the student's first solo flight, the instructor must be present to assist in answering questions or resolving any issues that arise during the flight. To ensure the solo flight is a positive, confidence-building experience for the student, the flight instructor needs to consider time of day when scheduling the flight. Time of day is a factor in traffic congestion, possible winds, sun angles, and reflection. If possible, the flight instructor needs access to a portable radio during any supervised solo operations. A radio enables the instructor to terminate the solo operation if he or she observes a situation developing. The flight instructor must use good judgment when communicating with a solo student. Keep all radio communications to a minimum. Do not talk to the student on short final of the landing approach. Post-solo debriefing. During a post-solo debriefing, the flight instructor discusses what took place during the student's solo flight. It is important for the flight instructor to answer any questions the student may have as a result of a solo flight. Instructors need to be involved in all aspects of the flight to ensure the student utilizes correct flight procedures. It is very important for the flight instructor to debrief a student immediately after a solo flight. With the flight vividly etched in the student's memory, questions about the flight will come quickly. Correction of student errors. Correction of student errors should not include the practice of immediately taking the controls away when a mistake is made. Safety permitting, it is frequently better to let students progress part of the way into the mistake and find a way out. For example, in a weight shift control aircraft, the control bar is moved right to turn left. A student may show an initial tendency to move the bar in the direction of the desired turn. This tendency will dissipate with time, but allowing the student to see the effect of his or her control input is a valuable aid in illustrating the stability of the aircraft. It is difficult for the students to learn a maneuver properly if they seldom have the opportunity to correct an error. On the other hand, students may perform a procedure or maneuver correctly and not fully understand the principles or objectives involved. When the instructor suspects this, students should be required to vary the performance of the maneuver slightly, combine it with other operations, or apply the same elements to the performance of other maneuvers. Students who do not understand the principles involved will probably not be able to do this successfully. Pilot supervision. Flight instructors have the responsibility to provide guidance and restraint with respect to the solo operations of their students. This is by far the most important flight instructor responsibility. The flight instructor is the only person in a position to make the determination a student is ready for solo operations. Before endorsing a student for solo flight, the instructor should require the student to demonstrate consistent ability to perform all of the fundamental maneuvers. Dealing with normal challenges. Instructors should teach students how to solve ordinary problems encountered during flight. Traffic pattern congestion, change in active runway, or unexpected crosswinds are a challenge the student masters individually, before being able to perform them collectively. Visualization. SBT lends itself well to visualization techniques. For example, have a student visualize how the flight may occur under normal circumstances, with the student describing how he or she would fly the flight. Then, the instructor adds unforeseen circumstances, such as a sudden change in weather that brings excessive winds during final approach. Other examples of SBT can have the instructor adding undesired landing sites for balloon student pilots, rope breaks for glider students, and radio outages for instrument airplane students. Now the student must visualize how he or she will handle the unexpected change. During this visualization, the flight instructor can ask questions to check the student's thought processes. The job of the instructor is to challenge the student with realistic flying situations without overburdening him or her with unrealistic scenarios. Practice landings. The FAA recommends that in all student flights involving landing in an aircraft, the flight instructor should teach a full-stop landing. Full-stop landings help the student develop aircraft control and checklist usage. Aircraft speed and control take precedence over all other actions during landings and takeoffs. Stress landing in the first third of the runway to ensure there is stopping distance for the aircraft. If the student is unable to land in the first third, teach him or her to make an immediate go-around. If the student bounces an airplane on landing, teach the student to make an immediate go-around. By following these teaching guidelines, the student is better equipped to properly execute landings when he or she solos. Furthermore, by requiring the first solo flight to consist of landings to a full stop, the flight instructor has the opportunity to stop the flight if necessary. In gliders, a low-energy landing is the most desirable, based on current winds. This helps the student develop good off-field landing techniques. This is dependent on current weather, such as excess winds including crosswinds. Practical Test Recommendations. Provision is made on the Airman Certificate or Rating Application form for the written recommendation of the flight instructor who has prepared the applicant for the practical test involved. Signing this recommendation imposes a serious responsibility on the flight instructor. A flight instructor who makes a practical test recommendation for an applicant seeking a certificate or rating should require the applicant to demonstrate thoroughly the knowledge and skill level required for that certificate or rating. This demonstration should in no instance be less than the complete procedure prescribed in the applicable PTS. When the instructor endorses the applicant for the practical test, his or her signature on the FAA Form 8710-1 Airman Certificate and/or Rating Application is valid for 60 days. This is also true with a flight proficiency endorsement that is placed in the applicant's logbook or training record. Advisory Circular AC 61-65. These two dates should be the same. Completion of prerequisites for a practical test is another instructor task that must be documented properly. Examples of all common endorsements can be found in the current issue of AC 61-65, Appendix 1. This appendix also includes references to 14 CFR Part 61, Certification, Pilots, Flight Instructors, and Ground Instructors, for more details concerning the requirements that must be met to qualify for each respective endorsement. The examples shown contain the essential elements of each endorsement. It is not mandatory, but recommended for all endorsements to be worded exactly as those in the EAC. For example, changes to regulatory requirements may affect the wording, or the instructor may customize the endorsement for any special circumstances of the applicant. However, at a minimum, the instructor needs to cite the appropriate 14 CFR Part 61 section that has been completed. FAA inspectors and DPEs rely on flight instructor recommendations as evidence of qualification for certification and proof that a review has been given of the subject areas found to be deficient on the appropriate knowledge test. Recommendations also provide assurance that the applicant has been thoroughly briefed on the PTS and the associated knowledge areas, maneuvers, and procedures. If the flight instructor has trained and prepared the applicant competently, The applicant should have no problem passing the practical test. A flight instructor who fails to ensure a student meets the requirements of regulations prior to endorsing solo flight or additional rating exhibits a serious deficiency in performance. The FAA holds him or her accountable. Providing a solo endorsement for a student who is not fully prepared to accept the responsibility of solo flight operations, or providing an endorsement for an additional rating to a pilot not meeting the appropriate regulatory requirements, is also a breach of faith with the applicant. Aeronautical decision-making. As discussed on page 8-2, aviation training and flight operations are now seen as a system rather than individual concepts. The goal of system safety is for pilots to utilize all four concepts: ADM, risk management, situational awareness, and SRM, so that risk can be reduced to the lowest possible level. ADM is a systematic approach to the mental process used by aircraft pilots to consistently determine the best course of action in response to a given set of circumstances. Risk management is a decision-making process designed to systematically identify hazards, assess the degree of risk, and determine the best course of action associated with each flight. Situational awareness is the accurate perception and understanding of all the factors and conditions within the four fundamental risk elements that affect safety before, during, and after the flight. SRM is the art and science of managing all resources, both on board the aircraft and from outside sources, available to a single pilot, prior and during flight, to ensure the successful outcome of the flight. These key principles are often collectively called ADM. The importance of teaching students effective ADM skills cannot be overemphasized. While progress is continually being made in the advancement of pilot training methods, aircraft equipment and systems, and services for pilots, accidents still occur. Despite all the changes in technology to improve flight safety, one factor remains the same: the human factor. It is estimated that approximately 80% of all aviation accidents are human factors related. By taking a system approach to aviation safety, flight instructors interweave aeronautical knowledge, aircraft control skills, ADM, risk management, situational awareness, and SRM into the training process. Historically, the term pilot error has been used to describe the cause of these accidents. Pilot error means that an action or decision made by the pilot was the cause of or contributing factor to the accident. This definition also includes the pilot's failure to make a decision or take action. From a broader perspective, the phrase human factors related more aptly describes these accidents, since it is usually not a single decision that leads to an accident, but a chain of events triggered by a number of factors. The poor judgment chain, or the error chain, describes this concept of contributing factors in a human factors-related accident. Breaking one link in the chain is all that is usually necessary to change the outcome of the sequence of events. The best way to illustrate this concept to students is to discuss specific situations that lead to aircraft accidents or incidents. The following is an example of the type of scenario that can be presented to illustrate the poor judgment chain. A private pilot with 100 hours of flight time made a precautionary landing on a narrow dirt runway at a private airport. The pilot lost directional control during landing and swerved off the runway into the grass. A witness recalled later that the aircraft appeared to be too high and fast on final approach, and speculated the pilot was having difficulty controlling the aircraft in high winds. The weather at the time of the incident was reported as marginal VFR due to rain showers and thunderstorms. When the aircraft was fueled the following morning, 60 gallons of fuel were required to fill the 62-gallon capacity tanks. By discussing the events that led to this incident, instructors can help students understand how a series of judgmental errors contributed to the final outcome of this flight. Weather decision. On the morning of the flight, the pilot was running late and, having acquired a computer printout of the forecast the night before, he did not obtain a briefing from flight services before his departure. Flight planning decision/performance chart. The pilot calculated total fuel requirements for the trip based on a rule of thumb figure he had used previously for another airplane. he did not use the fuel tables printed in the pilot's operating handbook, POH, for the aircraft he was flying on this trip. After reaching his destination, the pilot did not request refueling. Based on his original calculations, he believed sufficient fuel remained for the flight home. Fatigue/failure to recognize personal limitations. In the presence of deteriorating weather, the pilot departed for the flight home at 5 p.m. He did not consider how fatigue and lack of extensive night flying experience could affect the flight. Fuel exhaustion. With the aircraft fuel almost exhausted, the pilot no longer had the option of diverting to avoid rapidly developing thunderstorms. He was forced to land at the nearest airfield available. On numerous occasions during the flight, the pilot could have made decisions which might have prevented this incident. However, as the chain of events unfolded, each poor decision left him with fewer and fewer options. On the positive side, the pilot made a precautionary landing at a time and place of his choosing. VFR into IMC accidents often lead to fatalities. In this case, the pilot landed his aircraft without loss of life. Teaching pilots to make sound decisions is the key to preventing accidents. Traditional pilot instruction has emphasized flying skills, knowledge of the aircraft, and familiarity with regulations. ADM training focuses on the decision-making process and the factors that affect a pilot's ability to make effective choices. Timely decision-making is an important tool for any pilot. The student who hesitates when prompt action is required, or who makes the decision to not decide, has made a wrong decision. Sometimes, sound ADM calls for going against procedure. For example, in the event of an engine fire, the pilot initiates an emergency descent. Some POHs call for mixture to be enriched during an emergency descent. But what if the power plant is engulfed in flames? Emergencies require the pilot to think, assess the situation, choose, and execute the actions that assure safety, not act in a rote manner. It is important for flight instructors to teach students that declaring an emergency when one occurs is an appropriate reaction. Once an emergency is declared, Air Traffic Control, ATC, gives the pilot priority handling. 14 CFR Section 91.3, Responsibility and Authority of the Pilot in Command, states that, in an in-flight emergency requiring immediate action, the pilot in command may deviate from any rule of this part to the extent required to meet that emergency. Flight instructors should incorporate ADM, risk management, situational awareness, and SRM throughout the entire training course for all levels of students. AC 60-22, Aeronautical Decision Making, provides background references, definitions, and other pertinent information about ADM training in the GA environment. Figure 8-7. The decision-making process. An understanding of the decision-making process provides students with a foundation for developing ADM skills. Some situations, such as engine failures, require a pilot to respond immediately using established procedures with little time for detailed analysis. Traditionally, pilots have been well trained to react to emergencies, but are not as well prepared to make decisions which require a more reflective response. Typically during a flight, the pilot has time to examine any changes that occur, gather information, and assess risk before reaching a decision. The steps leading to this conclusion constitute the decision-making process. When the decision-making process is presented to students, it is essential to discuss how the process applies to an actual flight situation. To explain the decision-making process, the instructor can introduce the following steps with the accompanying scenario that places the students in the position of making a decision about a typical flight situation. Defining the problem. The first step in the decision-making process is to define the problem. This begins with recognizing that a change has occurred or that an expected change did not occur. A problem is perceived first by the senses and then is distinguished through insight and experience. These same abilities, as well as an objective analysis of all available information, are used to determine the exact nature and severity of the problem. One critical error that can be made during the decision-making process is incorrectly defining the problem. For example, failure of a landing gear extended light to illuminate could indicate that the gear is not down and locked into place, or it could mean that the bulb is burned out. The actions to be taken in each of these circumstances would be significantly different. Fixating on a problem that does not exist can divert the pilot's attention from important tasks. The pilot's failure to maintain an awareness of the circumstances regarding the flight now becomes the problem. That is why, once an initial assumption is made regarding the problem, other sources must be used to verify the pilot's conclusion is correct. While on a cross-country flight, Brenda discovers her time en route between two checkpoints is significantly longer than the time she originally calculated. By noticing this discrepancy, she has recognized a change. Based on insight, cross-country flying experience, and knowledge of weather systems, she considers the possibility that she has an increased headwind. She verifies that the original calculations are correct and considers factors that may have lengthened the time between checkpoints, such as a climb or deviation off course. To determine if there is a change in the winds aloft forecast and to check recent pilot reports, she contacts FlightWatch. After weighing each information source, she concludes that the headwind has increased. To determine the severity of the problem, she calculates a new ground speed and reassesses fuel requirements. Choosing a course of action. After the problem has been identified, the pilot evaluates the need to react to it and determines the actions that may be taken to resolve the situation in the time available. The expected outcome of each possible action should be considered and the risks assessed before the pilot decides on a response to the situation. Brenda determines the fuel burn if she continues to her destination and considers other options. Turning around and landing at a nearby airport, diverting off course, or landing prior to her destination at an airport en route. She considers the expected outcome of each possible action and assesses the risks involved. After studying the chart, she concludes there is an airport which has refueling services within a reasonable distance along her route. She can refuel there and continue to her destination without a significant loss of time. Implementing the decision and evaluating the outcome. Although a decision may be reached and a course of action implemented, the decision-making process is not complete. It is important to think ahead and determine how the decision could affect other phases of the flight. As the flight progresses, the pilot must continue to evaluate the outcome of the decision to ensure that it is producing the desired result. To implement her decision, Brenda plots the course changes and calculates a new estimated time of arrival. She also contacts the nearest AFSS to amend her flight plan and check weather conditions at the new destination. As she proceeds to the airport, she continues to monitor ground speed, aircraft performance, and weather conditions to ensure no additional steps need to be taken to guarantee the safety of the flight. Factors affecting decision-making. It is important to stress to a student that being familiar with the decision-making process does not ensure he or she has the good judgment to be a safe pilot. The ability to make effective decisions as PIC depends on a number of factors. Some circumstances, such as the time available to make a decision, may be beyond the pilot's control. However, a pilot can learn to recognize these factors that can be managed and learn skills to improve decision-making ability and judgment. Recognizing hazardous attitudes. While the ADM process does not eliminate errors, it helps the pilot recognize errors and, in turn, enables the pilot to manage the error to minimize its effects. 2 steps to improve flight safety are identifying personal attitudes hazardous to flight safety and learning behavior modification techniques. Flight instructors must be able to spot hazardous attitudes in a student because the recognition of hazardous thoughts is the first step toward neutralizing them. CFIs should keep in mind that being fit to fly depends on more than just a pilot's physical condition and recency of experience. Hazardous attitudes contribute to poor pilot judgment and affect the quality of decisions. Attitude can be defined as a personal motivational predisposition to respond to persons, situations, or events in a given manner. Studies have identified 5 hazardous attitudes that can affect a pilot's ability to make sound decisions and exercise authority properly. Figure 8-8. Figure 8-8 text. Pilots should examine their decisions carefully to ensure that their choices have not been influenced by a hazardous attitude. The 5 hazardous attitudes. Anti-authority. Don't tell me. This attitude is found in people who do not like anyone telling them what to do. In a sense, they are saying, no one can tell me what to do. They may be resentful of having someone tell them what to do, or may regard rules, regulations, and procedures as silly or unnecessary. However, it is always pilot prerogative to question authority if it seems to be in error. Impulsivity. Do it quickly. This is the attitude of people who frequently feel the need to do something, anything, immediately. They do not stop to think about what they are about to do. They do not select the best alternative, and they do the first thing that comes to mind. Invulnerability. It won't happen to me. Many people believe that accidents happen to others, but never to them. They know accidents can happen, and they know that anyone can be affected. They never really feel or believe that they will be personally involved. People who think this way are more likely to take chances and increase risk. Macho. I can do it. Pilots who are always trying to prove that they are better than anyone else are thinking, I can do it, I'll show them. Pilots with this type of attitude will try to prove themselves by taking risks in order to impress others. While this pattern is thought to be a male characteristic, women are equally susceptible. Resignation. What's the use? Pilots who think, what's the use, do not see themselves as being able to make a great deal of difference in what happens to them. When things go well, the pilot is apt to think that it is good luck. When things go badly, the pilot may feel that someone is out to get me, or attribute it to bad luck. The pilot will leave the action to others, for better or worse. Sometimes such pilots will even go along with unreasonable requests just to be a nice guy. End of Figure 8-8 text. In order for a student to self-examine behaviors during flight, he or she must be taught the potential risks caused from hazardous attitudes and, more importantly, the antidote for each. Figure 8-9. For example, if a student has an easy time with flight training and seems to understand things very quickly, there may be a potential for that student to have a macho, hazardous attitude. A successful CFI points out the potential for the behavior and teaches the student the antidote for that attitude. Hazardous attitudes need to be noticed immediately and corrected with a proper antidote to minimize the potential for any flight hazard. Figure 8-9. Text. Students in training can be asked to identify hazardous attitudes and the corresponding antidotes when presented with flight scenarios. Hazardous attitude. Macho. Steve often brags to his friends about his skills as a pilot and how close to the ground he flies. During a local pleasure flight in a single-engine airplane, he decides to buzz some friends barbecuing at a nearby park. Antidote. Taking chances is foolish. Hazardous attitude. Anti-authority. Although he knows that flying so low to the ground is prohibited by the regulations, he feels that the regulations are too restrictive in some circumstances. Antidote. Follow the rules. They are usually right. Hazardous attitude. Invulnerability. Steve is not worried about an accident since he has flown this low many times before and he has not had any problems. Antidote. It could happen to me. Hazardous attitude. Impulsivity. As he is buzzing the park, the airplane does not climb as well as Steve had anticipated, and, without thinking, he pulls back hard on the yoke. The airspeed drops, and the airplane is close to stalling as the wing brushes a power line. Antidote. Not so fast. Think first. Hazardous attitude. Resignation. Although Steve manages to recover, the wing sustains minor damage. Steve thinks to himself, it doesn't really matter how much effort I put in. The end result is the same whether I really try or not. Antidote. I'm not helpless. I can make a difference. End of Figure 8-9 text. Stress management. Learning how to recognize and cope with stress is another effective ADM tool. Stress is the body's response to demands placed upon it. These demands can be either pleasant or unpleasant in nature. The causes of stress for a pilot can range from unexpected weather or mechanical problems while in flight to personal issues unrelated to flying. Stress is an inevitable and necessary part of life. It adds motivation and heightens the individual's response to meet any challenge. Everyone is stressed to some degree all the time. A certain amount of stress is good since it keeps a person alert and prevents complacency. However, the effects of stress are cumulative, and if not coped with adequately, they eventually add up to an intolerable burden. Performance generally increases with the onset of stress, peaks, and then begins to fall off rapidly as stress levels exceed a person's ability to cope. The ability to make effective decisions during flight can be impaired by stress. Factors, referred to as stressors, can increase a pilot's risk of error in the flight deck. Figure 8-10. Figure 8-10 text. 3 types of stressors that can affect pilot performance. Physical stress, conditions associated with the environment such as temperature and humidity, noise, vibration, and lack of oxygen. Physiological stress, physical conditions such as fatigue, lack of physical fitness, sleep loss, missed meals leading to low blood sugar levels, and illness. Psychological stress, social or emotional factors such as a death in the family, a divorce, a sick child, or a demotion at work. This type of stress may also be related to mental workload, such as analyzing a problem, navigating an aircraft, or making decisions. End of Figure 8-10 text. One way of exploring the subject of stress with a student is to recognize when stress is affecting performance. If a student seems distracted or has a particularly difficult time accomplishing the tasks of the lesson, the instructor can query the student. Was the student uncomfortable or tired during the flight? Is there some stress in another aspect of the student's life that may be causing a distraction? This may prompt the student to evaluate how these factors affect performance and judgment. The instructor should also try to determine if there are aspects of pilot training that are causing excessive amounts of stress for the student. For example, if the student consistently makes the decision not to fly, even though weather briefings indicate favorable conditions, it may be due to apprehension regarding the lesson content. Stalls, landings, or an impending solo flight may cause concern. By explaining a specific maneuver in greater detail or offering some additional encouragement, the instructor may be able to alleviate some of the student's stress. To help students manage the accumulation of life stresses and prevent stress overload, instructors can recommend several techniques. For example, including relaxation time in a busy schedule and maintaining a program of physical fitness can help reduce stress levels. Learning to manage time more effectively can help pilots avoid heavy pressures imposed by getting behind schedule and not meeting deadlines. While these pressures may exist in the workplace, students may also experience the same type of stress regarding their flight training schedule. Instructors can advise students to self-assess to determine their capabilities and limitations and then set realistic goals. In addition, avoiding stressful situations and encounters can help pilots cope with stress. Use of resources. To make informed decisions during flight operations, students must be made aware of the resources found both inside and outside the flight deck. Since useful tools and sources of information may not always be readily apparent, learning to recognize these resources is an essential part of ADM training. Resources must not only be identified, but students must also develop the skills to evaluate whether they have the time to use a particular resource and the impact that its use would have upon the safety of flight. For example, the assistance of ATC may be very useful if a pilot is lost. However, in an emergency situation when action needs to be taken quickly, time may not be available to contact ATC immediately. During training, CFIs can routinely point out resources to students. Internal resources. Internal resources are found in the flight deck during flight. Since some of the most valuable internal resources are ingenuity, knowledge, and skill, pilots can expand flight deck resources immensely by improving their capabilities. This can be accomplished by frequently reviewing flight information publications, such as 14 CFR and the Aeronautical Information Manual, AIM, as well as by pursuing additional training. A thorough understanding of all the equipment and systems in the aircraft is necessary to fully utilize all resources. For example, advanced navigation and autopilot systems are valuable resources flight instructors must ensure students know how to use. If students do not fully understand how to make use of the equipment, or if they rely on it so much that they become complacent, it can become a detriment to safe flight. With the advent of advanced avionics with glass displays, GPS, and autopilot, flying may seem inherently easier and safer, but in reality it has become more complex. With the update of the Instrument Practical Test Standards, PTS, to include electronic flight instrument displays, flight management systems, GPS, and autopilot usage, knowledge of internal resources becomes an important component of flight training. As discussed in the section on flight instructor qualifications, instructors must be familiar with the components of each aircraft in which they instruct to ensure students understand the operation of the equipment. Checklists are essential flight deck resources for verifying that the aircraft instruments and systems are checked, set, and operating properly, as well as ensuring that the proper procedures are performed if there is a system malfunction or in-flight emergency. Students reluctant to use checklists can be reminded that pilots at all levels of experience refer to their checklists, and that the more advanced the aircraft is, the more critical checklists become. With the advent of electronic checklists, it has become easier to develop and maintain personal checklists from the manufacturer's checklist, with additions for specific aircraft and operations. In addition, the AFM/POH, which is required to be carried on board the aircraft, is essential for accurate flight planning and for resolving in-flight equipment malfunctions. Other valuable flight deck resources include current aeronautical charts and publications, such as the Airport/Facility Directory, A/FD. It should be pointed out to students that passengers can also be a valuable resource. Passengers can help watch for traffic and may be able to provide information in an irregular situation, especially if they are familiar with flying. A strange smell or sound may alert a passenger to a potential problem. The PIC should brief passengers before the flight to make sure that they are comfortable voicing any concerns. External resources. Possibly the greatest external resources during flight are air traffic controllers and flight service specialists. ATC can help decrease pilot workload by providing traffic advisories, radar vectors, and assistance in emergency situations. AFSS can provide updates on weather, answer questions about airport conditions, and may offer direction-finding assistance. The services provided by ATC can be invaluable in enabling pilots to make informed in-flight decisions. Instructors can help new students feel comfortable with ATC by encouraging them to take advantage of services, such as flight following and flight watch. If students are exposed to ATC as much as possible during training, they feel confident asking controllers to clarify instructions and are better equipped to use ATC as a resource for assistance in unusual circumstances or emergencies. Throughout training, students can be asked to identify internal and external resources, which can be used in a variety of flight situations. For example, if a discrepancy is found during pre-flight, what resources can be used to determine its significance? In this case, the student's knowledge of the aircraft, the POH, an instructor or other experienced pilot, or an AMT, can be a resource which may help define the problem. During cross-country training, students may be asked to consider the following situation. On a cross-country flight, you become disoriented. Although you are familiar with the area, you do not recognize any landmarks and fuel is running low. What resources do you have to assist you? Students should be able to identify their own skills and knowledge, aeronautical charts, ATC, flight service, and navigation equipment as some of the resources that can be used in this situation. Workload management. Effective workload management ensures the essential operations are accomplished by planning, prioritizing, and sequencing tasks to avoid work overload. As experience is gained, a pilot learns to recognize future workload requirements and can prepare for high workload periods during times of low workload. Instructors can teach this skill by prompting their students to prepare for a high workload. For example, when en route, the student can be asked to explain the actions that need to be taken during the approach to the airport. The student should be able to describe the procedures for traffic pattern entry and landing preparation. Reviewing the appropriate chart and setting radio frequencies well in advance of need helps reduce workload as the flight nears the airport. In addition, the student should listen to the Automatic Terminal Information Service, ATIS, Automated Surface Observing Systems, ASOS, or Automated Weather Observing System, AWOS, if available, and then monitor the Tower Frequency or Common Traffic Advisory Frequency, CTAF, to get a good idea of what traffic conditions to expect. Checklists should be performed well in advance so there is time to focus on traffic and ATC instructions. These procedures are especially important prior to entering a high-density traffic area such as Class B airspace. To manage workload, items should be prioritized. This concept should be emphasized to students and reinforced when training procedures are performed. For example, during a go-around, adding power, gaining airspeed, and properly configuring the aircraft are priorities. Informing the tower of the balked landing should be accomplished only after these tasks are completed. Students must understand that priorities change as the situation changes. If fuel quantity is lower than expected on a cross-country flight, the priority can shift from making a scheduled arrival at the destination to locating a nearby airport to refuel. In an emergency situation, the first priority is to fly the aircraft and maintain a safe airspeed. Another part of managing workload is recognizing a work overload situation. The first effect of high workload is that the pilot begins to work faster. As workload increases, attention cannot be devoted to several tasks at one time, and the pilot may begin to focus on one item. When the pilot becomes task-saturated, there is no awareness of inputs from various sources. Decisions may be made on incomplete information, and the possibility of error increases. Figure 8-11. During a lesson, workload can be gradually increased as the instructor monitors the student's management of tasks. The instructor should ensure that the student has the ability to recognize a work overload situation. When becoming overloaded, the student should stop, think, slow down, and prioritize. It is important that the student understand options that may be available to decrease workload. For example, locating an item on a chart or setting a radio frequency may be delegated to another pilot or passenger. An autopilot, if available, may be used, or ATC may be enlisted to provide assistance. Chapter Summary. This chapter discussed the demonstration, performance, and telling and doing training delivery methods of flight instruction, SBT techniques, practical strategies flight instructors can use to enhance their instruction, integrated flight instruction, positive exchange of flight controls, use of distractions, obstacles to learning encountered during flight training, and how to evaluate students. After an intensive look at ADM with suggestions for how to interweave ADM, risk management, and SRM into the teaching process, it closes with a discussion of CFI recommendations.
Additional information on recommendations and endorsements can be found in Appendix C, Certificates, Ratings, and Endorsements.